we are going to look at some other types of equations today, which is not very specific, but one type is going to be rational equations that involve a lot of fractions. So like in this warm-up here, if you're adding two fractions together, you need to get a common denominator. So on this one, my common denominator would be 3x, so I'd have to multiply by my fancy version of 1, 3 over 3, and x over x. And then, now that they have a common denominator, I can write it as a single fraction. And now it is a single rational expression. To solve a rational equation, the first thing you want to do is determine any restrictions on your solutions. So things that aren't in the domain of your expression or that make your denominator equal to 0 can't be solutions. You're going to want to factor your denominators so you can find those, and then find a common denominator and add. I like to look at my restrictions first. In your homework, sometimes it just asks for the restrictions and not to solve, so make sure you read the directions. If I look at my two fractions here, neither one of them can have a denominator equal to 0. First one's 2, no way to have that equal to 0. But on my second one, if x is -1, my denominator is 0, and I can't divide by 0. So my restriction is x cannot be equal to -1. So if we get that in the end, we're going to have to say it's not going to work. All right. Now let's go ahead and actually take my two fractions on the left, get a common denominator, and subtract them. Right-hand side of my equation is just kind of chilling. So I'm going to need to multiply my first fraction by x plus 1 over x plus 1, and my second one times 2 over 2. And then I'm going to go ahead and add some extra parentheses here. Remember, things are grouped by your fraction bar, but I like to have the parentheses anyways. Okay, so I have 2x minus 3 being multiplied by x plus 1 now, over 2 times x plus 1, and then 2 times 3x over 2 times x plus 1, so my denominators match. Now remember, you have to follow order of operations, which means you need to do those multiplications on top before you subtract your two fractions. So I'm going to multiply 2x minus 3 times x plus 1, which is going to give me, after a little distributing, that, and then 2 times 3x is just 6x. Let me go ahead and combine a couple terms here. That'll get me a -1x in the middle there, save myself some rewriting. And now that I've done my multiplication, I could do it on bottom, but I'm actually not going to. Sometimes it's handy, sometimes it's not. Now I'm going to go ahead and do my subtraction, and I can combine my -x and my 6x that I'm subtracting to get a -7x. All that's still equal to x. Okay, since my left-hand side is being divided by 2 times the quantity x plus 1, I'm going to go ahead and undo that division by multiplying both sides by 2 times x plus 1. Make sure you put some parentheses around it. Left-hand side, those will divide out to 1. Right-hand side, I will actually have to multiply. So I'm going to multiply my 2 times my x plus 1 and get 2x plus 2, and then multiply that times my x and get 2x squared plus 2x. Now it's just a normal quadratic equation. Actually, if you subtract 2x squared, it turns into a linear equation. And then you just have -7x minus 3 equals 2x. I'm going to add 7x, which gives me 9x equals -3. And then you can divide by 9 and simplify to get x equals -1/3. Check with your restrictions. The only thing we couldn't have was x equals -1, so x equals -1/3 should be fine. You can plug it back into the original and go all the way through and check if you want to make sure. I'm going to give you guys a little intro to this one and then have you try it from there. So reminder, if you have denominators that aren't factored, you're going to want to factor them to see what your restrictions are, and if you need to find common denominators, you make your life easier. So restrictions, I can't have x be equal to 2 or be equal to 0, because those would make my denominators of my rational expressions be 0. So remember those restrictions when you're solving. And then if you're solving, you're going to want to go ahead and get your common denominator, which means you'll have to multiply your first fraction times your missing factor of x. So you'll have to multiply by x over x. And then your second fraction doesn't actually need anything. It has both factors in its denominator already. So see if you can take it from there. Okay, so from there, I'm going to go ahead and multiply my 3x plus 2 and my x together, because order of operations, I need to do that before I add my two fractions. And then if I go ahead and add those together, now that I have a common denominator, I'm just going to erase and condense this here into a single fraction. Now I'm dividing my fraction on the left by a denominator of x times x minus 2, so let's multiply both sides by that to undo that division. So on the left, those divide out to 1. On the right, this is kind of a key thing that can help save you some work. Instead of multiplying all that together, if you notice that you have a common factor of x on the top and bottom, go ahead and divide those out to 1. And then I just have to take negative 1 times my x minus 2, which gives me negative x plus 2. That'll save us a lot of work. And then go ahead and, since it's quadratic, get 0 on one side. And you have a common factor of 3x that you can factor out. Set your factors equal to 0, and you'll get x equals 0 and negative 1. Check your restrictions. We can't have x equals 0, but x equals negative 1 should be fine. We're going to look at one last rational equation. So if you notice here, instead of getting a common denominator on the right, my two fractions already have a common denominator. They're just not on the same side of my equation. So I'm just going to subtract over 3 over x minus 3 so that my two that have a common denominator are on the same side. And then you have, if you go ahead and combine them to a single fraction, x minus 3 over x minus 3 equals 3. But anything divided by itself is equal to 1, so I come up with 1 equals 3. Well, 1 is not so much equal to 3, so that means this is going to have no solution. Switching equation types, so if I have an equation with a radical, I'm going to get my radical by itself on one side of my equation if possible, and then to undo a root, I need to raise both sides of my equation to the power that matches my radical. I also need to plug my potential solution back in and check it, because we could get extraneous solutions on these. So if I'm solving this radical equation, it has a square root. So to get to my variable that's trapped inside of my square root, I'm going to need to square both sides of my equation, which if you think about why squaring both sides of your equation works, squaring something is taking it times itself. And then if you think about how you are used to breaking down radicals, well, multiplying those radicals together gives you two factors of 15 minus 2x inside. Well, that means you have two factors that match. You can bring that to the outside, or you can think about undoing your square, and you just get 15 minus 2x. So if you are squaring everything that's inside of a square root, you just undoes it. So a little bit of rearranging here to get 0 on one side, and then factoring. Let me think. I'm going to need x and x, and then negative 15. Positive 5, negative 3 should do it. Yeah. So you'll get solutions of x equals negative 5 and positive 3 to set each of those, if you set each of those equal to 0. At least it looks like it. We do need to check. So go back to your original equation before you squared both sides, back to the very original, and plug those in one at a time and check it. So if x equals negative 5, we're going to have square root of 15 minus 2 times negative 5, and we're trying to see if that equals the same thing as what I have on the right. Well, that's square root of 25 equals 5. That is a true statement. X equals negative 5 works fine. How about x equals 3? 15 minus 2 times 3, we need to see if that equals negative 3 or not. Well, that's square root of 9. Square root of 9 is really just positive 3. That's the principal square root. So no, that one did not work. This one has two separate radicals on the same side of your equation. So to start with, I'm going to show you what you don't want to do. Well, it's tempting to just square both sides because you see a square root. If you square the left-hand side, think about what you're doing. It's not all inside a single radical. You have two separate radicals, and you have to multiply everything times everything else and distribute it, which is going to be a heck of a mess. So we're going to do something different instead. Back to the beginning. A better choice is to get one radical on each side of your equation. So I'm going to add square root x over, and then I have 3 plus square root x on the right-hand side. Now I'm going to square both sides, so still squaring both sides. It's still going to be a little bit messy on the right, but it is easier to square just a radical plus a number than it is to do two separate radicals. So on the left, I just get x minus 3. On the right, if I multiply those together, I get 9 plus a 3 square root x plus another 3 square root x plus square root of x times itself is just going to be x. Combine some like terms. So that'll give me 6 square roots of x. And then variables all over the place. Let's go ahead and subtract x, which just gives me negative 3 equals 9 plus 6 square roots of x. And then get our radical by itself again as a good idea. Let's make this negative 12 equals 6 square root x. I could square both sides now, but that would give you 36x equals 144. It's easiest just to divide both sides by 6. And then square it now that your radical is by itself. You'll end up with x equals 4, and yes, we do need to check it by plugging it back in. So if you plug it back into the original, we've got square root of, that's just going to be 1, minus square root of 4 is 2. 1 minus 2 is not equal to 3. So this one is no solution. All that work for no solution. Always kind of a bummer. Alright, so let's look at this one. It's cube root instead of square root. We're going to use the same strategy, get one radical on either side here. And then if I am looking at cube roots instead of squaring both sides, I'm going to need to raise both sides to the third power to get my 3 factors of those to undo my cube root. So this one's nice because it was all inside single cube roots on both sides, so I just end up with what was inside. And then I'm going to subtract x to get 0 on one side. Oh, factoring. This one would be a little bit messier. I'm going to factor by grouping, so I'm going to find the two numbers that multiply to 4 times 1 and add up to my middle term of negative 5. Negative 1 and negative 4 will do it. So I'm going to rewrite that middle term. And then I can factor out a 4x for my first two and a negative 1 for my second two terms, which means they share a factor of x minus 1, and then that leaves me with 4x minus 1. Okay, so it's factored. I can set each factor equal to 0, get x equals 1. The other one, let me write it out, it's a little bit more complicated. You'll end up with x equals 1/4. You do need to check those, but I'm just going to tell you, hey, they both work, guys, instead of making you do it. One last one. So the 4/5 power is really a radical in disguise. So I'm just going to rewrite this as the 5th root of x plus 1 to the 4th minus 81, and then treat it like I have been my radical equations. So let's get the radical by itself on one side by adding 81 to both sides. And now I do have this raised to the 4th power. To undo my 4th power, I'm going to need to take the 4th root of both sides. So if you take the 4th root of both sides, you're just going to be left with the 5th root of x plus 1 equals, if you break that down, 9 and 9, 4 factors of 3, so equals positive and negative 3. Then to undo my 5th root, I need to raise both sides to the 5th power. So if I take that radical to the 5th power, I'll just get x plus 1. I have both positive and negative 3 that I'm taking to the 5th power, so I'm going to write these separately. You could write them together, but just be careful if you do. So you have x plus 1 equals 243, and x plus 1 equals negative 243. So 242 and negative 244 look like potential solutions. You do need to plug them back in and check. So I'll run through that real quick. I like to plug it back into the version with the radicals because it's easier to think about. So that'd give me 5th root of 243, which is just going to be 3. Raised to the 4th power is 81. Yep. And then fifth root of negative 243 is negative 3 to the fourth power is 81, and 81 minus 81 is 0, so yeah, we're good to go.